the distance on a circle. So this is, technically this is 11.4, but I'd call it 10.2.5. All right? Because it's part of arc, you need to know arc measures in order to do arc length. So we want to throw them together. So we talked yesterday, circumference was distance on the distance on a circle. Yes, sir.
I can get my notebook.
You want just blank paper so you don't have to worry about it?
Yeah.
Help yourself, man. Plenty of them back there, folks. Yep. We also said real quickly yesterday what the formula for circumference was.
2 pi r.
Good. So we call it circumference is pi times the diameter, or circumference is 2 pi r. Okay. Either way, it means the same. It means the exact same thing. It's just depending upon what you are given. Sometimes you'll be given diameter, sometimes you'll be given radius, and obviously if you're given a radius, you just have to convert to the diameter. So the diameter, if you recall, is the chord. Somebody turn off their music, please. Thank you. Turn it off. Chord through the center of the circle. It creates a semicircle, remember? And the diameter equals twice the radius. Excuse me. So that's where we're at so far. Now, one of the things that we have to look at in terms of the difference between the measure of an arc versus the arc length. If I look at just those two things right there, the measure of the arc versus arc length, what is, just looking at it, what's different between the two?
One's length and one is angle.
All right. I kind of like what you were going with that one. See how on the arc, we always put the arc value, that little curve? Isn't that symbol very similar to what we would put into an angle measure? Remember how I always hook the angle? Think of it that way. And this is always going to be the measure of your central angle. Okay? It's always going to be the measure of the central angle. It's always something in degrees. Always. Okay? Whereas this arc length is going to be a portion of the circumference. And when you start thinking about this circumference generally is going to have pi in it, 2 pi r. Your calculators, if you're going to calculate circumferences by pressing a couple buttons, your calculator will actually leave your answers in terms of pi. That's what we call an exact answer. Very similar to what we did with the exact answers with square roots. Same idea. You'll have pi in your answer. Okay? So, it's quite delicious. So, example then. If I have a circle, a radius of 8, let's do this first. If I have a radius of 8, what's my diameter?
16.
Good. My radius is 8. My diameter is 16. What's the circumference? What is it? You said it. What was the formula for circumference 2 seconds ago?
My diameter.
Okay, so what's double your radius is what? So your answer is 16 pi.
Oh, we don't have to.
No.
That's the exact answer.
Yep, exact answer. It's just like what we did before with square roots. You know, like Justin, you're asking what the whole 45, 45, 90, you know, if it was 1, 1, root 2, if your side lengths of the right triangle for 45, 45, 90 were 4s, it was 4, 4, and 4 root 2. We didn't multiply it out because that's just a waste of time. It's the same basic principle. We're gonna leave things in our exact answers. It's cleaner. There are times that it'll ask you, hey, round it to the nearest foot, round it to the nearest hundredth, things like that. But more often than not, when we do things that have arc length or circumference, I'm gonna ask that you guys leave it in an exact answer, okay? All right. So if you know that the circumference, the distance around the object is 16 pi, if I wanted to figure out a portion of it, for example, let's say this is 80 degrees here. I wanted to figure out how much of the circle, how much of the circle's diameter that is. There's a formula. What's that?
When you just do like 16 pi divided by 80.
You're close.
No, the tangent.
We're not getting into the trig stuff here. You're close to it. What happens here is, in order to figure out what arc length is, there's kind of a goofy formula. Arc length is always going to equal your central angle over 360 times 2 pi r. Okay? It's a very basic looking formula, and there's going to be 3 different ways that we can write this out. So your arc length, bless you. What's another name for 2 pi r? Okay, times pi, correct. So depending upon what you know, pi times the diameter is also known as the circumference. So there's 3 different ways to write this out. There's 3 different ways to write out the formulas for arc length. Every single one of them is still going to have pi in the answer. And it's just a matter of knowing the right way to type something together to make it work. Okay? If you don't have one of those multi-view calculators, if you don't have one of those, you can always just put pi in at the end. It's going to be just fine. Okay? So in our example here, excuse me, we had a central angle of 80, we had a radius of 6, we knew that radius of 8, which gave us a diameter of 16, which gave us a circumference of 16 pi. I could use any one of those 3 values to set it up. So here's how it would start. 80 over 360, and I'll do it long form, 2 times 8 times pi, because that's what my radius was. There's my central angle, and there's my pi. So now, quite literally, all you have to do in your calculator is this. Move this over so you can see it. Make your fraction bar. 80 over 360 times 2. Oops, I forgot to get out of it. And don't forget to get out of your fraction. Times 2 times 8 and hit enter. It's going to give you some answer. It'll give you some fraction, some simplified fraction. To that, all you have to do is slap a pi next to it. And that's it. And there's your answer. If you have the multi-view calculator, you can do it one step further. Instead of typing it straight through like that, you could actually type it in and put the pi next to the 8, and it will give the pi in the answer. Mine won't do that. Yours will. Yes, ma'am?
Could you put like 32 over 9 and
Yep. Yeah, when you're multiplying fractions, you're multiplying straight across. It doesn't matter where the next value winds up. So if you wrote 32 pi, normally how we would say that is 32 pi over 9 instead of 32 over 9 pi. It's just it's a cleaner way of saying something. The reason being that we say it like that is because next year when you get into your unit circle, you're going to have angles that are 2 pi over 3, and that's how you would write it. We don't write 2/3 pi. we usually say 2 pi over 3. That's all. It's just another way of the lingo, if you will. All right. So I'm just trying to get you guys accustomed to vocabulary for later on. Okay? So that when you see it, you're like, oh.
What's going to be 2/3?
What's that?
We divided it into 4.
Did what?
You divided the circle into 4 pieces.
That was just a quick, this had nothing to do, I was just making something up. Okay, I wasn't, 2/3 is actually 120 degrees on the unit circle, so, but don't worry about it now. As a reference angle, 60 degrees up, sine and cosine values.
I thought I was in geometry.
You are.
Okay.
Yeah.
We were talking about
No, it all comes back around.
next year is about
Oh my gosh, every
boomerang.
day, we're gonna hear that.
next year's going to be
You ever thrown a boomerang?
Never came back to me.
Yes, sir.
Well,
Like a little bit, but not like all the way like.
Yeah, I've tried boomerang before. Like, they used to have remember the triangle ones, the star ones? They were like a Nerf, you could just whip them sideways. And those would usually come back and put around, but I could never get a regular boomerang to work. I've tried before. I would throw it, and it just have to go out there and pick it up.
Yeah.
Yeah, I could never figure it out.
I can't even throw a frisbee.
I got my last. Mr. Murphy.
Yes, sir.
There is a certain way to throw a boomerang.
I'm sorry, what?
There is a certain way to throw a boomerang.
Yeah, I just was never able to do it correctly. All right, so try another one. Excuse me. So in this one here, guys, in this one here, we are given looks like we have a central angle of 110. I have a radius given at 3, and the first thing that they ask is, what is the measure of AB? Now, measure of AB is going to be different than arc length, correct?
Right.
Yes, because the measure of AB is going to equal what?
6.
What is the measure of AB?
What is the measure of the angle?
It's 110.
Oh.
Because the measure of the arc, we just said this. If you were getting this wrong, you might want to write that down. The measure of the arc is the measure of the central angle. It's 110. We just wrote that, right? Yeah,
Sure,
just-
yeah, I just
and we did it for
double-checked,
2
yeah.
days, right? Yeah, that's what I thought. So if you got that wrong, please be sure you wrote that down. Now, the difference then is the arc length, you use that central angle to go through it. So the arc length will be written it might be written out differently. It might say, what is the length of AB?
Sorry.
It might even say AB. Okay, it might say that. It might say length AB. It could say arc length AB. All 3 of those mean the same, okay? Since we don't have a diagonal, a chord, if you will, that's going from A to B, we know that we have to be talking about the arc. Yes, sir?
Okay, so A goes to the center and B goes to the center. Wouldn't that mean A and B are congruent?
Those are radii. It's completely different than what we're looking at, okay? So again, throw it all together. Your arc length is going to be 110 over the 360 times 2 times 3 times pi.
It's going to be 11 pi over 6.
Very good. Your answer is going to be 11 pi over 6. Okay? As you put it all through the calculator, that's what it spits out. You don't have to try and simplify it on your own. Okay? I would suggest having a calculator out in front of you right now and actually pushing the buttons because you're going to screw this up. Okay? I know it's not very difficult to do, but you might want to try. I don't know. Call me crazy.
You're crazy.
Thank you.
You're very welcome.
All right, do that one. Let's do the measure of the arc, and then we'll do the arc length. We'll do it backwards. See if we can figure that one out. What's the measure of the arc? Yes, ma'am.
8, 150.
Good. Now to go to the arc length then, what do you have to use for your central angle? What's your central angle for arc ACB? 210. Good. A lot of times that's what they'll do. They'll flip things around, change the lettering on you, and ask you to go different directions. So when you go arc length the other way, move this over a little bit. You get 210 over 360, 2 times 12 times pi. What's that? It's easy.
I got to the first zero. Is there one on the pie? It looks like a pie, like it's first.
Now you're okay with the zeros, right? Zeros drop. 12 and 36. 12 goes into 36 how many times? 3 times. So this goes away. This becomes a 3. 3 goes into 21 how many times? 7 times 2?
14.
It's a beautiful thing. You know what that's called? It's called
The answer is 14 times.
It's fine. I'm not going to take the calculator away from you, but I'm just saying that it's okay to, simplify fractions. Fractions are your friend. Okay? Excuse me. All right, take a minute. Can you see that they're the red ones? Yep. All right, try those. Degrees for your angles because they simplify quickly. So 60 over 360, 2, 8, and a pi. That goes away. This becomes a 1/6. This becomes a 3, so it's 8 pi over 3.
1 times 8.
I did math. Use your where's your calculator? It's almost April. You need to have a calculator. You understand that? I have this conversation with you pretty regularly. Well, you need to go find one, okay? You guys gotta get one. You never lose your phone, you don't lose Chromebooks, you don't lose your 2 phones, but guys, you've got to find a calculator, and you have to have one. And it's, I'm not trying to overwhelm you on this one, but you gotta have one.
You already did.
Same thing. You get the same idea as things simplify out. 11 pi over 3. Once again, the calculator would spit that out for you. Now, if you look at the 2 here, the next one, excuse me, is the radius the same? What happened to the angle? It doubled. So what do you think happened to the answer? It doubled. Did you get 22 pi over 3? Yeah. And that happens. That'll happen. If you have the same radius, obviously, if the radiuses are the same, the circles are the same because they're the same size. If the circles have the same radius, that means if the angles are the same, they'd have the same length that they'd have to walk on. If you double the angle, you have to double the walk and go from there. All right. Now, one of the weird things that you can do is that you can work. Let's see if I got this linked right. You can work backwards off of this. Oops. Excuse me. Sometimes you have to work backwards. What'll happen is they'll give you the circle, they'll give you the central angle, they might give you the arc length, they might give you circumference, they might give you something where you have to find one of the pieces. So in this one, they're asking to find circumference. West ma'am. Well, hold on one second. They're asking us to find the circumference, correct? So suggestion would be then to write down one of the 3. Well, arc length is angle over 360 times the circumference. You okay with that? What's the arc length? 15. So 15 has to equal 60 over 360 times the circumference. How do you undo multiplying by a fraction? You multiply by its reciprocal. Well, the reciprocal here becomes 1/6, or I'm sorry, the fraction becomes 1/6, so you multiply it by 6, and you get 6 times 15 is? Is that what you got here?
Yeah, what I did is 360 divided by 60. Then I had some little pieces I made, and then I did that times 15.
Gotcha, I gotcha. You went the long way.
A long way. How was that a long way?
How's that the long way? I multiplied by a reciprocal. How is that any longer than anything else? It was one step.
Sorry.
Okay.
The step she did was one step as well.
Okay. This one we're going to find the radius. This one we're going to find the radius. So what we would do is first of all, we write out what you know. Since we know an arc length and we're trying to find a radius, I'm going to write out the formula with the radius in it. Everybody okay with that? Just start with the formula. Now I fill in the blanks of things that I know. I know that the arc length is 18 pi. I know my angle is a right angle. I'm multiplying that by 2 pi and r. So what I would do first is simplify out your fraction. 90 over 360 is a fourth. Calculator would do that. So you get 18 pi is, well, that becomes 2 over 4. So if I put this in my calculator, it'll come up with pi over 2. Okay. Yes, sir.
So, wait, from this point you would get the 1/4, you'd simplify, and then the next step after that you would subtract. Wait,
I'm not subtracting anything. What I'm saying is
oh, I see, never
What?
mind.
you need to put those first pieces together in the calculator. 90 over 360 times 2 pi. The calculator will spit out pi over 2. Which means you have to multiply by the reciprocal. What's the reciprocal of pi over 2? Nope. 2 over pi. So you multiply both sides by 2 over pi. What's pi divided by pi? It just cancels out. It becomes 1. Your answer is 6.
I just did 18 times 336 divided by 90 divided by 2.
There's a bunch of ways of going about it. I try to set it up to show that it just winds up being a one-step equation. There's a lot of different ways to write it because it's a ratio. You can set up the ratios and do all that stuff. There are many different ways of going about it. I'm not going to say one way is better than the other. I've always thought that if I write it out, it does two things. Forces me to remember the formula, and then it works on the simplifying of a fraction. That's all. But you know, not terrible. What's wrong?
That was really fast. I don't know what we're doing.
That's all right. We'll do another one. Oop, I need to get that forward. I didn't look that forward. Sorry. From time to time, they will give you something with a decimal. Yeah. From time to time, they will give you something with the decimal. They will not put it in terms of pi. Guys, that's when you actually have to press the button in your calculator and do the decimal equivalencies. This does happen pretty regularly. Okay? So you've got an arc length of 4675 going from here to here. And you have your central angle of, as we all yell, 290. It's not. Okay? And they're asking you to find the circumference. So what I would do first is I would write down arc length in terms of the circumference. So your arc length, angle over 360 times your circumference. In this case, your arc length is 4675. What do you do to undo multiplying by a fraction? You multiply by its reciprocal. You don't need to simplify anything, you're just putting it into your calculator. There's your circumference. But I'm going to change it up. Instead of asking circumference, I want to figure out what my radius is. So let's get the decimal equivalent of what you have right now on the left-hand side. You have 360 divided by 290 times 4675. What is it? And change? All right. So right now in the calculator, you guys have 58.03 blah, 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 blah. That equals 2 pi r. Are we okay with that? So whatever that answer you have in your calculator, you need to divide that by 2 pi. Here's the deal. When you divide by 2 pi, what do you have to put around the 2 pi? You've got to group it with parentheses. If you don't group it with parentheses, you'll divide it by 2 and then multiply it by pi. Calculator doesn't know the difference. So what I wanted to show you, if you have to find radius and you have to divide out by 2 pi, you need to make sure you group that last bit with parentheses. So we had 29 over 36 times 4675. There's our, it's 36, sorry. So here's our 58 and change. So that answer in your calculator, all I do is this, divided by 2, parentheses 2 pi. You have to put it in parentheses and then hit enter. There's your radius. When you ever have to round with decimals, always go 2 decimal places. So this one would be, 924. Okay. You have to go 924 on this one. That's about as goofy as this stuff can get, to be honest with you. That's about as goofy as this stuff gets in terms of having to find the radius because you have to divide by the 2 pi. Okay. Let's see if I can another one of this real quick. Excuse me. Yeah. All right, get the radius, please. Oh, I thought it was get out of the way where I can't see it. Okay, so you got the okay with this? Okay. Now to undo multiply, what do you do? I'm going to do multiply. So undo is this. We're going to divide this by 2 pi. Because if you look at the parentheses on it, you take 50 over 3 divide by 2. 0 divided by 2. So you get through it. That's all. That's what you're trying to do. Same idea. You do that. We have find the circumference. Sorry. Yard length was 15. Ceiling was 60. How do you multiply by a fraction? You multiply by its square. It's a lot of research. Gee willikers, lady. Oh, you know why? You know why spoon? Oh, you're doing the other direction. You're going this way. This one was just this. The red stuff wasn't going to be that. You might not have read that. If you're doing the bigger angle, yes, you're doing it correctly. We were finding the ones that did the same with the red, and that was the shorter side. That's all. You might have done, you did the other side. You just did the other side. You did it all right. You just did the other side. Okay. So right away, you've got your 2 pi r is going to equal 19.71 times 360 over 55. And then to that, you divide it out by your 2 pi.
Wait, I have a question. So in the page, it says that 360 goes under its
Yeah. Yeah, it's central angle over 360. But then because then how do you undo multiplying by a fraction? You multiply by its reciprocal.
Oh, so
When you go to the other side, yeah. So in your calculator, you have 19.71 times. Oh, thank you. I'll fit. There's your crummy decimal. To that crummy decimal, you have to divide it by 2 pi. So divide by parentheses 2 pi. There's my radius. Okay. And that's how it works. You guys give me to the third hour. I have to upload the chapter 11 stuff because it's out of the book. I just realized I didn't do that. What I'd like you to do. And then we'll worry about perimeter stuff tomorrow. All right, we'll get through those, and like I said, I'll have that uploaded here in a minute. I've just realized that chapter 11 isn't uploaded.
Whoa, you got it. I thought you bought my combo.